So we're going to combine finding inverses and evaluating compositions of functions to show whether or not functions are inverses. So if we had a function f defined by 2x minus 6 and a function g defined by 2x plus 6, let's determine if f and g are inverses of each other. And the way you do that, if f of g of x is equal to g of f of x, which is x, then the functions are inverses of each other. So what this is saying is, if I evaluate in this direction, plug g into f, or if I evaluate in this direction, plug f into g, I should get x in return if the functions are inverses of each other. So that's exactly what we're going to do. We're going to find f of g of x and g of f of x. So we're going to compose the functions together in both directions. Alright, so this notation here, we're going to start with the innermost. G of x is 2x plus 6, so that's where we're going to plug into the innermost parentheses. So in this direction, we want f of 2x plus 6. So the rule for f is 2x minus 6. So let's rewrite the rule for f with an open set of parentheses instead of x. So f is 2x minus 6. And in this case, we're going to plug in 2x plus 6. Let's distribute the 2. Gives us 4x plus 12 minus 6, which gives us 4x plus 6. So now what that's telling me is that f and g are not inverses because I didn't get x. Let's evaluate in the other direction. G of f of x is asking you to plug f into g. So here's f of x, and here's f of x. Let's plug f of x's equivalent, 2x minus 6, into the innermost parentheses. So really we want g of whatever f of x is equal to, 2x minus 6. So this is telling us to plug 2x minus 6 into g for x. So here's the rule for g, 2x plus 6. So we're going to set up the rule for g with an open set of parentheses instead of x. So 2x minus 6 is being plugged into that. 2x plus 6 is g. 2x plus 6. And what we're substituting for x in this case is 2x minus 6. Let's distribute. 4x minus 12 plus 6, which gives us 4x minus 6. Again, they are not inverses because we didn't get x in return. Let's say we had f of x is x squared minus 8. Let's find f inverse of x and show f inverse of x is the inverse of f of x. So what we're going to do is first find the inverse, and then we're going to show that it's the inverse by finding f of g of x and g of f of x. So just recall, step 1 to find the inverse was express the function in terms of y equals x squared minus 8. Now we can interchange the position of x and y, and now we could solve for y. And to get rid of something being squared, take the square root. Square root of x plus 8 equals y. So now we know that f inverse of x is radical x plus 8. So we're done with finding the inverse. Now let's show that these are inverses of each other. So we're going to have to find f of f inverse of x. We're also going to have to find f inverse of f of x. To show that they're inverses, you have to compose in both directions and get x in both directions. Alright, so f inverse of x is radical x plus 8. So we're going to plug in radical x plus 8 in for f inverse of x. F inverse of x is radical x plus 8. So we want f of radical x plus 8. So let's plug radical x plus 8 into f for x. So f was x squared minus 8. So let's plug in radical x plus 8. Well, when you square a radical, it simply gets rid of the radical sign. Radical x plus 8 squared is radical x plus 8 times radical x plus 8. A radical times itself is simply the radicand. So x plus 8 minus 8 is x. One more step. Now we have to find f inverse of f of x. So now what we're doing, we're plugging f into the inverse of x. The innermost parentheses here is f of x, and I know what f of x is equal to. X squared minus 8. So we want f inverse of x squared minus 8. Here's the inverse here. X plus 8. What are we plugging in? X squared minus 8. So the inverse of f, let's rewrite the inverse for f with an open set of parentheses instead of x. Radical x plus 8. Take a look. There it is. X plus 8. X plus 8. But now what we're plugging in is x squared minus 8. There's a 1 instead of in front of the parentheses here. Let's distribute it, which gives us the square root of x squared minus 8 plus 8. Well, the 8's cancel. So really, this is the square root of x squared, which is x. So, since we got x in both directions, we can assume that f and f inverses are indeed inverses of each other.